Alrighty, in this video we're going to take a look at auto layouts. So we've seen how we can use rect transforms and how powerful they are at allowing us to sort of set up the elements in the way that we want to. However, not all elements are going to fit nicely into the concept of a rect transform. In fact, there could be a lot of different situations where custom code is going to be required to position and size elements. Unfortunately, that can't be avoided. If you want a system that has a grid layout, for example, you're going to have to write code that puts elements into a grid. So instead of just Unity throwing up their hands and saying, okay, fine, that's the limitation of the GUI system. We're not going to try to make anything better from here. They instead created this auto layout system. And the auto layout system, just like I said, allows elements to be positioned through logic, through actual code, but still play nicely with the editor and still work with the same workflow that we've been using. In fact, Unity has provided a handful of auto layout components that we can use to put together our UIs. Now, I'm not going to jump into any code in this video. We're not going to look at how to create our own auto layouts. We're going to be doing that in the second part of this series when we put together the game. But for now, we can at least look at the existing auto layout groups and kind of start to get a feel for how the auto layout system works. Because auto layout systems are not trivial, and Unity spent a lot of time putting together an auto layout system that can handle a variety of different circumstances. And we can just take the existing pre-built auto layouts as a template for how we can build our own. And in their own right, they're very useful anyway, so they're very important to understand. So let's go ahead and get started. As always, I'm going to come up here and create a new canvas. Once I've done that, I'm going to switch over into an orthographic scene view. And I'm going to introduce a panel. I'm not going to worry about anchors in this video. I'm just going to dump the panel in the center of the screen. Now let's say we had an inventory window, and we wanted that inventory window to display as a grid. What would we do? Well, we could go into code, and we could write our own code to calculate the position and widths of all our elements, but we don't have to, because of the auto layout system. So what you'll see if I add buttons, for example, pretending that these buttons are slots in your inventory. Whoops, that was a panel. That was not a button. That's a button. So these are buttons that we're just pretending are part of our inventory system. Now I could manually go ahead and configure them, but then again, what would happen as I resized? What we really want is we want a grid. And we want all of these buttons to be laid out in a grid. So how do we do that quickly and easily? Well, we jump over to the panel, we hit Add Component, we type in Grid, and we have what's called a grid layout group. Layout groups are a major component in the auto layout system. You can think of them as containers. They dictate to their children where their children should be positioned and sized. So if we click on this, instantly we get a grid. As we resize the parent, the grid follows properly. We could even combine a mask and a scroll view if we wanted to, and create a scroll view grid as well. So the grid has a variety of different parameters, such as starting corner, which is pretty straightforward. It's just what corner these guys start at. We have start axis, vertical or horizontal, and we have child alignment. So I could say upper center, because maybe upper center would be a more appropriate choice for an inventory window. Then I can change the size of the children. So note how I'm changing the size of the children, not within the child's rect transform, but within the parent itself. Then I can also change the spacing. Maybe give each X and Y value of 5, giving a padding of 5. In addition, layout groups typically also contain a padding, although they're not required to. So in this case, I can add a padding to the layout group, giving a top padding of 10, which will be consistent with the padding that I've given between the elements themselves. So that is a grid layout view. It's pretty straightforward, and it's something that we can use today pretty easily. Combine it with the mask and a scroll view, and you have a scrollable inventory. I mean, I don't know if it could really get any easier than that. Now let's talk about the other layout groups that are built in. So I'm going to create another panel, and I'm going to resize it a little bit. In this panel, I'm going to add a couple buttons. Then on the panel itself, I'm going to say add component. And this type, I'm just going to type in layout, because layout will give us a list of all the layout groups that we can choose from, at least the pre-built ones. Remember, building your own layout group is completely possible. So we have our grid layout group, our horizontal layout group, and our vertical layout group. So horizontal and vertical sound like, or do exactly what they sound like. There's the horizontal grid. So it just will fit all of the elements in with the sizes that makes the entire width of the container full. We can set the padding like we did before, maybe give it a left, top, right, and bottom of 10, and then give a spacing of 10. Then we can change the child alignment to whatever we want. In this case, it's not going to make a difference because every button is uniformly sized. So what happens with these children? What happens to their rect transforms? Well, you can see right now that their rect transforms are disabled. That's because they're being controlled by a layout group. I can move these buttons if I wanted to, but notice how they kind of fight to snap back into where they should be. That's because there's a set of events that are sent when certain things invalidate the current auto layout, and you can temporarily use the rect tool to override the position of a child, but the moment that the layout group finds out what happened, it's going to stuff the child back where it originally intended it to be. So you're not going to want to manually move around buttons if they're being controlled by a layout group, or any sort of control. So yeah, I mean, that's there's really not a whole lot to say about this without getting into the more intricate details of the auto layout system. I do, however, want to point out some things. I first want to point out how we can easily create a button that has an image next to it, such as a drop-down button. So let's go ahead up to our canvas, right-click our canvas, and create a UI button. Then inside of the button, what I'm going to do is I'm going to create a UI image. Then I'm going to set the image's sprite to a pop-up arrow. Then I'm going to set it to preserve aspect. Finally, I'm going to go back into the button itself, and I'm going to add a horizontal layout group to it. Notice how we now have an image button, a button with an image to the right-hand side of it. But you'll notice that the image is stretching, and I'm really not a big fan of that. So a way to fix the image from stretching is I can come into Add Component, and I can add what's called a layout element. Now a layout element is a component that allows us to override aspects of the auto layout system. It basically allows us to communicate to the auto layout system what our preferences are. What I'm going to do in this case is I'm going to check flexible width, and I'm going to set it to 0. What this effectively does is it means that this element, this child element within the button horizontal layout group is not allowed to be stretched, in the X direction anyway. So now you'll notice that as I move around this button, that image is always stuck to the right-hand side. And it's stuck to the right-hand side because it's refusing to be resized. It's like the parent element saying, you must be this size, and then the child element saying, no, I can't get any bigger, and then the parent saying, throwing up their hands and saying, whatever, be whatever size you want. And we'll fill in the rest with everybody else. So to maybe make this more appealing, I can click on the button, I can go into the horizontal layout group, and I can add a right padding of maybe 10. And now we have a button with an image on the right-hand side of it. So it's stuff like this that really shows the flexibility of the UI system. It really proves that we can put together a variety of complex user interface scenarios with very little work, just by mixing and matching with different elements. Because most of these components are meant to work together, which is really nice. There's one more scenario I want to talk about before we wrap up the auto layout groups, and that is, what if we want these buttons to be the biggest size that they can be but no bigger, and then have on the edge of this automatic layout group all the excess space? Meaning I want these buttons to not stretch. I want them to only be as big as they want to be. There's a couple ways I can do this, but the easiest way is to start off with adding a layout element to the buttons. Now this isn't going to be a complete solution, and you're going to see why very shortly. I'm going to hit Add Component and click on Layout Element. Remember, Layout Element allows us to override the behavior of an auto layout group. So what I'm going to do here is I'm going to set the flexible width to 0. Now you'll notice something kind of odd. That button is, well, it's not appropriately sized. There's a couple ways we can fix this. Inside of our layout element, we can set a min width, maybe a min width of 100, meaning that the button is going to be 100 units wide, but no bigger. Notice how when I stretch this layout group, the other buttons grow in size, whereas the one that I've constrained to not be flexible does not grow in size. However, specifying the min width is a little bit of a cop-out, so I'm going to deselect it. Instead, what we can do is we can go to Add Component, and we can add any layout group we want. For example, a horizontal layout group. And then we can go to the padding and set its its left padding to 10 and its right padding to 10. You'll notice now that the size of the button is determined by how much text is in it. And all the other buttons shrink or expand to fill the remaining space. If we were to go ahead and go to these other buttons and delete them, and then take the button that we've made, the button that we fixed so that it only is as big as it needs to, and duplicate it, notice how now there is empty space in the layout group. Also notice how the buttons will get smaller, but they won't get bigger. The reason why adding a layout group to the button prevents it from getting smaller, or sets its preferred width to the size of its actual child element, is that we've introduced, well, a layout group. By introducing a layout group, these values, you can think of them as getting automatically computed now. So the preferred width of this button is now automatically computed to being the size of the text because of the horizontal layout group that I added to it. Okay, let's finish up this discussion with weights. So let's say I have two buttons, and I want one button to fill half or 75% of this layout group, and the other button to fill the rest. It's very easy to do. I can click on this button, and I can set its flexible width to, let's say, 0.7. And I can set this guy's flexible width to 0.3. So now you'll notice, because the flexible width is a percentage, a value between 0 and 1, you'll notice that we now have a 30-70 split by default until they get too small. So as long as there's room to spare, there's a 30-70 split. But once there becomes no room to spare, they become their preferred width, or a value between their preferred width and their minimum width. See, they'll never get smaller than their minimal width. Their minimal width says, okay, parent, you can't tell me to get smaller than this. Whereas their preferred width says, okay, I would like to be this size. And then the flexible width says, I'm willing to grow this much. And that's it. Okay, so just to recap, in this video, we talked about the auto layout groups. And again, the auto layout groups allow us to have our children automatically placed within our elements, and auto layout groups are controlled by code. You can write your own and it'll show up properly in the inspector. We have 3 primary auto layout groups that we can use by default, and that is the grid, the horizontal, and the vertical. Next up, we can dictate how the auto layout system works by using a layout element component and overriding the minimum, preferred, and flexible values. Finally, in order for a button to know, or an element to know how big it needs to be, you have to make it into a layout group so that it queries its children to determine its full size. That's why, again, the buttons only expanded to the size of their text when we added the horizontal layout group to them. Anyway, the layout group is a really, really cool feature. It allows us to do some awesome stuff. We'll be definitely taking a look at it in the next part of this series when we put together our game, because we're going to be using it for the grid in the center of the screen. But I think that just about wraps up what I wanted to talk about, so we'll see you guys in the next video.